Let's look at 47 from section 1.3. Our directions are to find a value for a so that the function f is continuous everywhere. F in number 47 is defined as a piecewise function. We follow the rule x squared minus 1 when x is less than 3, and we follow the rule 2ax when x is greater than or equal to 3. So essentially there are two branches of this graph. This is parabolic. It is a parabola that's shifted down one space, and we follow that rule to the left of x equals 3. This is linear. It has a slope of 2a and a y-intercept of 0 when x is greater than or equal to 3. So what we want then graphically is for this branch to connect to this branch, and we're going to do that with the definition of continuity. So let's remember that definition real quick. Number one, to be continuous at a point, we need for f of that point to be defined. So we're going to say f of c is defined. We've got to have a point there. Number two, we need the limit as x approaches c to exist. So we need the limit as x approaches c. It's very important here we talk two-sided limit, not just left, not just right, but the two-sided to exist. So we have the limit as x approaches c of f of x exists. And then finally, number three, for that definition of continuities, we need the previous two statements to be equal to one another. So we need the limit as x approaches c of f of x to be equal to f of c. So let's get looking at our question. F of c is defined. Do we have that? Can we plug 3 into this function? Yes, we can. So I'm going to go number one, f of 3, that's the place where the function rule changes. So I assume that's the place where there's going to possibly be a discontinuity. F of 3, it looks like we'd use the second rule, and that's going to be 2a times 3 for a result of 6a. Once I know what a is, I will have a for sure defined value for f of 3. Number two, let's check the limit. In order to do that, a two-sided limit, we go back to that existence rule for a two-sided limit. And if the two-sided limit exists, both the left and right-hand limits will also exist. And because we change rules at 3, we're going to need to check both the left and right-sided limits. So let's go the limit as x approaches 3 from the left. And from the left of 3, we use the top rule, x squared minus 1. So since that's a polynomial, we can go direct substitution. That's 3 squared minus 1. That's 9 minus 1. So that's 8. Now for the limit as x approaches 3 from the right, we'd use the second rule, 2ax, because this uses all the points to the right of 3. So 2ax, and that's 2a times 3. And that's 6a. So in order for the two-sided limit to exist, both the left side and right side limit not only need to exist, but they need to be equal. We need 6a to be equal to 8. 6a equals 8. And if that's the case, then a is 8 over 6, or 4/3. So now they both the left hand and right hand limits are equal when a is equal to 4/3. So finally, for number 3, the limit as x approaches 3 two-sided of our piecewise defined function f of x is equal to f of 3, and both of those values are equal to, it turns out it's going to be 8. When you multiply 6 by 4/3, you get 8. When you multiply 6 by 4/3, you get 8. So we're equal to 8 when a is equal to 4/3. So there's our answer to 1.3. And really, even though we found what we were asked for, a is 4/3, the answer itself uses the full definition of continuity to be a complete good result.